Cos of A minus 90 degrees is not equal to negative sine of A. And in this video, I'm going to explain why. Now, the reason I'm making this video is because I've noticed a pattern with students where they actually simplify this expression like this. And I think it comes from this. See, let's say we were given sine of A minus 90 degrees. So first of all, they'll look at this and notice that the angle is negative. So in reductions and even in cofunctions, we usually have the angle written first and then the theta or the A or whatever letter that we're using. And so they would rewrite it like this. They'll say this is equal to sine and then put the angle here, which you know that our angle is negative 90 degrees. So they'll say negative 90 degrees. And as you can see, the A is positive, so positive A. But then when they get to this point, they would say that, okay, this is not necessarily cofunctions yet, but they could make those cofunctions by taking out a common factor of -1. And they would do that, but then they would take the common factor of -1 and put it in front of sine, as if it's the coefficient of sine. So then we would have sine, and then this now becomes a positive 90 degrees, and this becomes a negative A. And then after, they would notice that sine of 90 degrees minus A is a cofunction, and so it's going to be equal to cos of A. So because we still have that negative there, they'll say this is equal to negative cos of A. And if you use the app on the Play Store, Photomath, to simplify this expression, it will indeed give you this answer. But if that is the case, then we should be able to use the same method of simplifying to simplify this expression. But if I put this onto Photomath, you see that it does not give us negative sine of A. Instead, it gives us positive sine of A. And here's the reason why this method is not correct. The thing is that you're taking out a common factor from an angle, and you're placing that common factor in front of a function. That is not possible. This part is an angle. This is the coefficient of your function, which are really just normal numbers with unit values like 1, 2, 3. Those are those values that we have there. You cannot multiply a normal number by an angle. And this is because angles are not quantities. So now I'm going to show you 3 methods that we can actually use to simplify this expression, and it will not be equal to negative sine of A, but sine of A. So here's the first method. So first of all, notice that we have A before the actual angle. So let's just put this in an order that it will be easier to work with. So I'm going to put the angle first, which is negative 90 degrees, and then plus A. And then now we're going to take out a common factor from this angle, but it's not going to go in front of the function. It's going to stay in the bracket. So this is what we're doing. We have cos, and then out of this negative 90 and positive A, we take out a common factor of -1. And we open our bracket, and now we'll be left with positive 90 degrees. Remember, it's just like saying this divided by the negative. And then A divided by that negative would be negative A. Okay, so now at this point, do you remember that if you have cos of negative x, this would be equal to positive cos of x. And here's the reason why really. Because if we have a negative angle, normally we would just add 360 degrees to that. And so that creates the reduction cos of 360 degrees minus x. And as you can see, 360 degrees minus x, that reduction lies in the 4th quadrant where cos is positive. So this simplifies to cos of x. And so we're going to apply this to this expression. Notice we have negative and then 90 degrees minus a. So we're going to treat our 90 degrees minus a as if it is our x. So since cos of negative x is equal to cos of x, then it means that cos of negative bracket 90 degrees minus a would be equal to positive cos of 90 degrees minus a. And then from this point, we would use cofunctions. The cofunction for cos of 90 degrees minus a is equal to sine of a. And that is why cos of a minus 90 degrees is actually equal to positive sine of a. So that is the first method, and here is the second method. So in the second method, we're going to look at the fact that this angle is actually negative because a in our reduction really represents an acute angle. Then we are subtracting by 90 degrees. So this angle is negative. And when our angle is negative, we add 360 degrees. So if we add 360 degrees to the angle that we have here, what's going to happen is we will have cos, and then 360 minus 90 is 270 degrees. And then we still have a positive a. And then this 270 degrees, we can break it up into 90 degrees and 180 degrees. So this is cos of 90 degrees plus 180 degrees. That gives us 270 degrees. And then, of course, we have the plus a. And the reason we're doing this is because we're trying to use cofunctions again. But this time, we're going to use cofunctions like this. So you see the 180 degrees and the plus a, we will group those together. And so this is actually saying cos of 90 degrees plus 180 degrees plus a. Now, do you remember the cofunction that states that if we have cos of 90 degrees plus x, that this should be equal to negative sine of x? Well, we're going to simplify this in the same way, but now 180 degrees plus a is going to act as our x. So it means that this function is going to simplify to negative sine of 180 degrees plus a. Then, of course, using reductions, if we have negative and then our sine of 180 degrees plus a, as you can see, this reduction belongs in the third quadrant where tan is positive but sine is negative. So this gets reduced to negative sine of a. We still have that negative outside. And so if you distribute that negative into the bracket, we get positive sine a. So that's the second method, just adding 360 degrees to the negative angle and using cofunctions. And here is the third method. In this method, we can rewrite this in an order that it's going to be easier to work with, putting the angle first, so negative 90 degrees plus a. And then we'll take out a common factor of negative 1 from the angle. So we will have cos, and then we have negative. When we open a bracket, we will be left with 90 degrees minus a. So at this point, remember again that cos of negative x is equal to positive cos of x. In the same way, cos of negative bracket 90 degrees minus a would be equal to positive cos of 90 degrees minus a. Now in the first method, we got to this point, but then we used cofunctions. In this method, we're going to use the compound angle formula. So this is simplified to cos of our first angle, which is 90 degrees, multiplied by cos of our second angle, which is a. And then because we have a minus, our sign would change to a plus. And then we're going to have sine of 90 degrees and sine of a. And so cos of 90 degrees, you can either use your special triangles, you can use the OHA rule, you can also use your calculator, or the actual graph of cos of x. Cos of 90 degrees would be equal to 0. And that is being multiplied by cos of a. Then we have plus sine of 90 degrees would be equal to 1 and multiplied by sine of a. Anything multiplied by 0 would be 0. And so our answer would just be 1 times sine of a, which is sine of a. So do you see that you have 3 methods that you can use to do this, but you need to remember how it simplifies. I would actually recommend method 1 as the easiest method to simplify this. So what you can do is actually study your cofunctions, the positive ones and the negative ones. Okay, so that is it for this video. That is why cos of a minus 90 degrees is not equal to negative sine of a.